So the first question is, what environmental stimulus triggers perception of movement? Is real movement necessary for us to perceive motion? So here I've put up just a bunch of dots, right? A bunch of circles on the screen, and they're clearly still not moving, but let's see what happens now. Okay, so if that worked well, you may have noticed that the dot changed locations on the screen, and if I did it properly, you may have perceived the dot as a sphere or a ball that maybe bounced along the screen. We know the circle wasn't really moving. It was a series of still shots. This is basically what video is. This is film. So when we are watching a movie, we are seeing a series of still shots, but our brain puts them together into seamless motion, a little more smoothly than I did with that circle. That tells us that we can perceive movement where there really isn't any, and that we do that all the time when we're watching a movie. So when we ask the question, then what determines whether or not we perceive movement? A simple hypothesis would be that maybe things just need to move from one location to another along our retina. So if we think of what our retina is and how the image of an object is on the retina, like the red dot, as that red dot changes position on the retina when we're looking at the screen, that allows our brain to figure out, oh, that red dot must be moving. But let's think about a second situation. What happens when our eyes track a moving object? So we're going to do a finger tracking demonstration. If you look at the picture where the doctor is holding up, his finger and the guy's looking at it, go ahead and do the same exact thing. Look at your finger and track it as you move it slowly left and right or up and down, but just keep your eye on your finger. As you do that, your eye tracking movements are keeping your finger directly in the same spot in the retina, on the fovea, as you move your finger. So the image of your finger doesn't actually move when we're doing this, when we are tracking a moving object. So in one case, if we stare straight ahead and you wave your finger, no, yes, the image of your finger will move left and right across your retina. But if you're tracking your finger, then the image does not move across your retina. But in both those situations, we know that our finger is moving. Same thing if you're tracking a basketball or a ladybug that's crawling along, right? We track it, keep it right on the retina. The image does not move along the retina, but we still know that the object's moving. So movement along the retina must not be necessary for movement to be perceived. It's one thing that can lead us to perceive motion, but it's not the only thing. What kind of conditions allow us then to perceive motion? Now, there are, of course, regardless of the condition, what we can think of as motion thresholds. So movement might be too slow for us to be able to perceive it. And examples are a plant or a child as it grows, right? And we aren't able to actually perceive these. We aren't able to see them happen in action because they're moving too slowly. The change is happening too slowly. Likewise, we don't really see a bullet that's been fired out of a gun. Some things just move too slowly for us to perceive motion. Other things move too quickly for us to perceive them. So these are what would be considered motion thresholds. So yes, Wonder Woman perhaps can see a bullet that's been fired out of a gun, but that's what makes her a superhero. You or I cannot see a bullet that's fired out of a gun. So here are the 4 situations that lead to perception of movement. Real movement, your finger moving, a basketball being dribbled. Those objects are actually moving and we definitely perceive them as actual movement. But there's also apparent movement, so the red dot that we saw earlier, as well as film and video. Now, for apparent movement, there are certain conditions that facilitate this. And let me just show you an example. If the amount of time between objects is too fast or too slow, it won't work. Here on the screen, there's a square, and it's, you might be perceiving it as moving from left, right, left, right, left, right. Now, let's see what happens if we move the positions further apart and maybe slow it down. So when we do that, it's moving too slowly. We don't perceive the square really moving across the screen anymore, do we? Now I'm going to speed it up. That's a little better, huh? A little better. All right, a little better. Now let's see what happens if I decrease the amount of time that the square is shown. Oh my. Now it looks like it's just sort of flashing, right? We don't get actual perceived movement. Let me increase the interval between the time it takes it to go from left to right. And move it a little bit closer together. Oops, sorry. Here we go. A little closer together. And once again, you might be perceiving the square moving left to right. So it's sensitive to a number of things: the interval, the duration that it's shown, and the position. If the interstimulus interval, the gap between where, say, the square is shown in one position versus another position is too short, less than 30 milliseconds, it'll probably appear like it's just a flashing square. If it's about 60 milliseconds, it should appear to move smoothly. But if we slow it down too much to 200 to 300 milliseconds, we lose apparent motion. It'll just sort of seem to show up one place versus another. And of course, it's also influenced by the distance between the stimuli. Another situation that leads us to perceive movement is when movement of one object makes it seem as if something else is moving. This is called induced movement, or it can be an example of induced movement. And one place that I've noticed this is at those drive-in car washes where you drive your car in, but you stay inside the car. And as the brushes and wheels and stuff move around the car, you might get the illusion that your car is moving forward or backward at different times. There's also what's called a movement after effect. So here we go. So you were just going to look at the screen here and keep your eyes fixated on the little red cross. So again, keep your eyes on the small red cross in the middle. And now you may see the expanding Buddha. And once again, keep your eye on the small red cross in the middle. You can blink normally, but just keep your eyes fixated there. And so as you keep your eyes on the middle of the screen there, you should get the illusion that the Buddha is sort of coming out and expanding. And so that's obviously an after effect. It's called the waterfall illusion because it happens out in nature. If you stare at a waterfall for a while and then you move your eyesight to the side, it might appear as if the rocks and twigs and stuff next to the waterfall are floating upwards for a moment. And that's the waterfall illusion. This is a movement after effect. You stare at movement in one direction, and then when it stops, we get the illusion of movement in the opposite direction. And so it implies that there are opponent process neurons in our movement perception system where a neuron might react one way when movement is, say, up, and another way when a movement is down. So we can think of a neuron as reacting through a neural signal and action potential represented by a line here, and its baseline level is like this. And when this motion detecting neuron detects movement, say from left to right, during this period of time, it goes crazy and starts firing quite a bit, signaling that it's detecting movement in one direction. But then when that stops, instead of going back to its baseline period, it might take a while to go back to baseline. And so for this period of time, it actually signals the opposite, because this neuron would normally be excited by movement to the right and inhibited by movement to the left. And we can think of it as if the neuron was fatigued. It just gets tired of firing so much and then takes a break. So those are the 4 different situations that lead to perception of movement: real, apparent, induced, and then the movement after effect.